Hello, everyone, and welcome to this fireside chat today on sustainability in IT. I'm your host, Archana Joshi. I've been doing IT since past almost nearly 21 years, but of late recently shifting my focus on environment, sustainability, and how as we who are working in IT can make a difference there. So today for this very interesting talk, I have an equally interesting guest here today. Please extend a warm welcome to Dinkar Gupta, who is a partner CIO CTO from KPMG based in Switzerland and has always been one of the forefront on everything in IT, especially in the European region. So very warm welcome to you, Dinkar, and we'll get started around this topic.
Thank you, Archana. Looking forward to the conversation.
Yeah.
I think we both have been spending a lot of our time on some of these emerging technologies for last many, many years, and keeps us still interested in this world, right?
That's right.
Mm.
Dinkar, if I look at ESG overall, right?
Mm-hmm.
Suddenly, past 2 years, it has gained traction, and we see everybody, right from school children to mainstream corporate, everyone talking about it.
Yeah.
But when you say ESG is a very vast gamut. It consists of right from your environment, it talks about social, it talks about diversity, it talks about governance. There are a lot of things. So how do you see all of this kind of getting into an IT and a technology context, and how do you see this shaping up?
Yeah, sure. That's always been a debate, right? And ESG is not a first attempt at that topic. We had corporate social responsibility, which was more focused around commitment towards social cause by an organization. We had environment, health, and safety, pretty closer to another topic, which is a favorite of mine for studying, which is complexity and safety science. That's been there for ages. So what happened is in each of these, the notion of being responsible towards society, so towards climate, was more of a good behavior rather than a mandate. With ESG, what's happening is the shift that you're seeing is it's becoming a mandatory thing for you to succeed in the market. I think that fundamental shift is causing the change in the behavior towards these concerns. It's not that concern towards climate or social equity or governance transparency is new. It's just that when you tie it to market, the invisible hand of the market, it starts to become business relevant. And when it starts to become business relevant, the amount of rigor and the overall social change required to make it happen changes a lot. And that doesn't confine itself to business, because as we both know through different communities at our work, the business is digital by definition these days, right? And when the business is digital, an underlying theme which is explicit in your business pursuit is technology, right? And that means ESG is not just a business imperative, but technology imperative. And if your technology is not ESG sensitive, if you are not sensitive about causes that are supported by ESG efforts, then you cannot help your business sustain longer. So one of the strategic themes that I'm driving at KPMG is called sustainable business agility. Now, sustainable business agility cannot be achieved unless sustainability at the core of your technology. So for me, that brings it together. There are elements of course, environment around being sensitive about environmental impact. However, there are also elements around classical HR topics, right? How we lead our people, what kind of opportunities we provide them, what kind of social impact we have on broader IT ecosystem associated social elements. And that's where partnering with our human resource colleagues becomes very, very critical. Even a topic which is very close to my heart, the topic of psychological safety, takes a big role in there, right? Equity and diversity, inclusion, all of those topics. And then governance for me is generally the element where we bring the fundamental element of trust, but trust at scale into the conversation. And once you start introducing transparency, once you start introducing required accountability towards society and environment, the governance starts to take shape. And with that renewed trust, you have a much stronger impact on both of these areas, whether it is environmental impact or social impact.
So a couple of interesting points you brought out, Dinkar. First is the fact that what was considered good behavior is now not just good behavior, it's plain good business sense as well. So if you are investing more into this kind of area, you see consumers mindset also changing, and they are getting attracted to the businesses who are showing a degree of social responsibility, awareness towards all these causes. So good behavior is also translating equally to the good business sense. So that's one angle that you brought out. Also, what is interesting aspect that you brought down, to make this good business sense, today it's all digital, and digital underlying means technology. So to do good business, you need good digital, and to do good digital, if you don't have good technology, you're pretty much down the drain. So that
Absolutely.
also is needed to make this sustainable, right? So if I try and take these points, what you just quoted, and expand it a little further, how do you kind of build that cause for somebody who is doing IT, which is so logical, which is so, I would say, coding, technology? We've never been taught in any of the engineering schools saying that, look at sustainability when you are coding. Nobody teaches us that. If you even go and talk to some developer or an engineer who is doing all these software programs, or somebody who is setting up some systems,
Mhm.
who would never even think of having sustainability and environmental at back of their mind. So how do you build this, I would say, focus within them to make sure that they truly feel for this cause? And I remember when we were speaking about it, you used a very nice word, say sympathy. So they
Yeah.
sympathize with this cause. What are your thoughts around it?
Yeah, very interesting thing. I don't know if it's a term which is currently pursued in industry, or I'm kind of creating a new term, but my idea of that came from exactly the same thing. When we, as software developers, right, there was this divide between people who develop software, operate it, and people who understand the underlying, the bare metal that runs, which means the hardware force. And what Martin Thompson and colleagues, when they were building technology, he introduced the concept called mechanical sympathy. That resonated quite well with a number of us, and the concept was pretty simple, which also borrowed an idea from another idea regarding how you can't just be a better driver or a better motorbike rider if you do not understand the machine underneath. I mean, you can drive, but if you understand the machine, you will be able to exploit as well as leverage the capabilities of that machine much better. The same concept applied to when we were looking at mechanical sympathy. We as software developers, whether I'm designing, whether I'm coding, whether I'm writing specification of requirements, or I'm testing it, if I'm aware the underlying hardware context in which my code at the end of it, our work product is code, right, runs, I'll be able to make better decisions regarding its design, regarding its reach, regarding its time and space of running. So I'm able to better exploit the underlying technology. If you extend the same concept to layer below that, your bare metal, your infrastructure, your technical infrastructure essentially consumes economical as well as environmental resources, water, electricity, underlying workforce, natural and other resources. What if we extend the same idea, and instead of just being mechanically sympathizing, we become climate sympathetic? So we extend the idea of mechanical sympathy to climate sympathy. And what if we start being explicitly aware about climate sympathy? So what does it mean? When I say I have mechanical sympathy, I understand that what runs on my motherboards, what runs on my CPUs, what kind of interactions happen when my networks are working, what happens when my network routers are caching certain information and are not able to pass it further. So I need to understand how the underlying tech works. I know what runs on those wires, when those wires are longer or smaller, when these are thicker or thinner, right? Similarly, if I understand that the underlying water consumption, the underlying electricity, the underlying coal that's getting burned is going to be impacting the kind of power I get out of my infrastructure, and how can I maximize impact of my work, as in terms of positive impact on that underlying resource consumption, I can not just efficiently utilize it and positively impact, I can also exploit it much better. To give you a quick concrete example, one of the topics that's being discussed quite heavily these days in the Green Software Foundation area is the element around load shifting and time shifting. Now, that's in a nutshell is nothing but you being able to decouple the processing as well as execution of your stuff, irrespective of at which space it is running, at which location, and at what time it is running. If you now understand that impact, that at a certain point in time, electricity is cheaper at a particular data center and not others, can you design your system that it is agnostic of where it is running? Which means it starts to bring your appreciation about standards, interoperability, being able to decouple from underlying infrastructure. So, and then you start, coming up at the higher layer. So the whole idea of being climate sympathetic is that with that awareness of the stuff that runs 2 layers down, your access, which means software, hardware, and then underlying natural resources, you are able to make better decisions. So maybe with that mindset, we can start to educate our colleagues in technology ourselves. We are not all well equipped right now. We are all learning, right? And how we make ourselves better equipped to make decisions which are sympathetic to climate as it is sympathetic to the underlying hardware. So that's essentially the concept.
Great. I really like the term climate sympathy. I'm sure at least in EcoITCon, we want to use that term a lot more courtesy you and with your permission, of course.
No, let's try to do that, right? This could be one theme which can help us spread different streams around it. So why not? We should.
Okay. And what I find interesting is that the term climate sympathy for you've got that concept extended from a term called mechanical sympathy. And I still can relate to it because I remember like when I was learning the car years ago, when I still remember I just turned 18, going to the school where they teach you cars. And the first day, of course, they told me where your accelerator, brake, clutches are. And the second day, that guy who was the instructor there, he tried to teach me what is under the hood. And my first question to them was, why are you telling me all this? I just need to sit in the car, manage the steering wheel and drive. And they were like, no, if you understand what is there within it, you will better appreciate at what speed, what needs to change, when do you need to do your stick shift and all of that. So
yeah,
I can definitely now understand that what that person was trying to get me is to make sure I understand the mechanics and be sympathetic to what is happening in the car. After all, it's a machine, but if I'm able to relate to it better, maybe my driving would improve is the hope they have. And I think that's a very, sorry, go ahead.
No, I was saying just to extend that example, programming 101, when we were taught late 90s, when we started developing coding, designing system, we were, as part of our operating systems, we understand locality of reference. Very simple, fundamental thing, and that concept was not for you to understand just programming, how things like caches within the CPU, within your infrastructure work, right? So if you understand locality of reference, then we started to understand how threads work, how processes work. Then we went, at higher level, etc. But at the end of it, if you understand how, to give a concrete technology example, if you know how the memory processing and memory locality works, I come from a Java background. We all were taught in day one of Java, the Java memory model. Now that's not hardware, but that is still the infrastructure on which Java runs. So if I understand how that machine works, that virtual machine underneath the hardware machine, I'm able to better exploit it for my advantage. But then I'm also able to better have a better impact on the resource utilization at that level. And I think that's the concept from an ESG perspective we are trying to be sympathetic towards. It's not exploiting resources for our benefit. That's always the case, that you can build more resilient, more scalable software. That's our benefit. But on the other hand, you also have an accountability to have better resource utilization, which is better for that underlying infrastructure, right? And that's where you can make decisions which will not just help you achieve better technology impact, scale, performance, resilience and other things, but you are also able to have better resource utilization, which means positive impact on underlying infrastructure's utilization.
Correct. And I think for our listeners who are listening in, especially those who have tuned in from academia, call out to you to see if you can bring in the concept of climate sympathy when you are teaching to your students about software. And I'm sure within us as industry leaders is also something that we need to be doing more and more with all the entry-level programmers as well as architects across different levels to make them understand this concept of climate sympathy. So that, let's say we understand this concept, Dinkar, but what does it mean when you say you have to now make this climate sympathy concept into action? Because one is understanding, but second is, let's say, when I say Simple things like when somebody says me that save energy, I know I have to go and switch off lights when not in use. So I know that's a direct action which I have to do. So in cases like this, when you say climate sympathy, what could be those 2 or 3 things you think an engineer, a software engineer, or a technologist can start doing uh, to make sure climate sympathy translates to action?
Sure, that's actually the whole area of research where many of our colleagues and us ourselves are trying to understand what does it mean. There are different efforts going on in this direction, and the work is happening at different layers, right? So you can speak at a level when you are programming software. You can speak at the level when you are designing systems. Any non-trivial system these days is a distributed system. Any non-trivial system more or less runs on virtualized infrastructure. So these two kind of give you the context. Do you need to design differently? So that becomes the area around system design and architecture. What kind of technology do you use? The choices that you make, where you bet on this technology is a good bet for me. That's where you can take certain actions. And last but not the least, from a what I call as an accountability framework around how you develop software, there are a couple of things you can do. So let me start the other way around from that area. So we know the idea of technical debt very well, right? What if you now start, annotating that topic with climate? What if you start using the term like climate debt? What about now the same concept of climate sympathy, right? So when I'm looking at the debt that you're creating, the debt, every software that you create is a debt for tomorrow. So if the kind of debt that you're creating, the kind of shortcuts you are creating, what if I start capturing those as, depends on what kind of impact you want to have. You can call it a carbon debt, you can call it a climate debt. I got really nice ideas when I was reading Bill Gates' book. He called the idea of green premium. Maybe we start introducing some of those terms. If you make certain choices of your design and technology, which is going to incur additional impact on underlying climate, I may start charging you some kind of climate premium on an internal. So that's like a governance structure in a technology firm, right? As architects, as IT governance mechanism, that can be some. Second is a continuous governance eye on it. That's how the ESG starts to come shape. What if I provide an explicit intent that I would like to have a positive impact on climate, which means in all my projects, when I'm looking at reviews of projects, when I'm reviewing its design, when I'm reviewing its delivery, when I'm reviewing how me and my team have made choices of vendors or of a technology, have I paid enough attention that I'm not incurring climate debt? Things like that, right? And then you can have incentives as well as consequences aligned to that. So that's like the whole management layer. The one thing, sorry, I just forgot to ask, this element of climate sympathy substantiates the case for cloud even further. Think, but if I'm running my own data centers and I want to do these kind of things, and compare to the kind of investments and the effort cloud vendors are doing, you have no chance to succeed on your own. And this is where, I'm going to steal a term from my company. We call it together for better. You can only be better for ESG if you work together with what I call the big three. I mean, there are many cloud providers, but a substantial amount of real estate on cloud is run by the big three. And look at the effort coming out. AWS even introduced sustainability as part of their well-architected framework, an explicit one. Microsoft has another one like that. Microsoft has got, and both of the cloud vendors have a sustainability related cloud offering now geared towards green IT. Google has for long done that, and Google even has a specialized awareness and certification program around it. So that's where you need to partner here with the cloud providers. Do not, I mean, just a suggestion from my side. Yes, everything can be done by engineer. If you ask me, I'll write my own cloud infrastructure as an engineer, but none of us would like to do that because it's a specialized job. So partner with cloud providers. This could also be one of the reasons to pushing your business case for cloud. That's why the whole idea of the ESG is more of a business imperative rather than just a good behavior thing, right? The third element is standards and their role in creating designs. If you look at things which is happening around the open carbon specification, right? Some of the work that's happening around Green Software Foundation, the standards are getting developed now. And which means that if you start adhering to these standards, you will start to speak a single language, and we all know the benefit of a single language, ubiquitous language in design. You start to develop patterns. You start to develop good practices, idioms. So you are not alone in solving a problem. You will have a number of patterns coming in, so you can design for that. If you look at the Green Software Foundation's page currently, you will start to see there are quite a lot of cloud native patterns already mentioned, which are ESG friendly. sustainable design. So you don't need to reinvent the wheel. There are a lot of colleagues, a lot of our industry experts who are coming up and trying to document all of these good designs as part of patterns and good practices, and you should leverage that. An associated aspect of that, which I find quite interesting, is an element of, my personal topic has been, we all know scope 1, scope 2, scope 3 emission topic. Everybody knows, right? Greenhouse gas. If I go to any of my colleagues or myself straight away as a technology saying, what does it mean? 95% of the chances you'll have no idea what it means. So how do you make that awareness as developer community, as technologists, as architects? What does it mean? And that's where good old ELITs come into the picture. As architects, as engineering managers, as product managers, start using the element of non-functional requirements there. Consider sustainability to be a first-class non-functional requirements category. And because it's a category, I'm being explicit, it's not that you have to have a, show me your sustainability. You can't show sustainability. What you will need to then understand, what are the different parameters? Don't say that, give me the most sustainable software. It's like somebody saying, give me the fastest performance, right? We know that when you talk performance, you talk about resource utilization, you talk about response time, you talk about latency and many other things. But once you start considering sustainability as that category of non-functional requirements, then you start to reason about these indicators, which parameters, which indicators, scenario. So an architecture-oriented approach to sustainability will help. And last but not the least, something to the core, which means programming and all. If you look at some of the idioms, some of the frameworks that are coming up, those are a lot more suitable to programming when you have to be climate sympathetic, right? Your climate sympathy is supported by certain frameworks, certain data structures, certain mechanisms, certain control structure. And I'm going to a very low level, but if I'm programming a particular module and I have to put in constructs regarding how I access data, how I go through conditional statements, do I keep some of the data cached in my piece or not? For everything, do I make a round trip latency out to a service which is running across the spectrum, which means my network hops? All of these somewhere down the line will have to have smaller impacts on your ecosystem. And if you look at the cumulative effect across millions of developers across the world, it's one small change here and there. How do you do programming will make a difference. So that's part, and still in the researches, but I have been looking at some of colleagues as well as some of the industry peers who are doing now research into, as we say, mechanically sympathetic. Now, how do you say, carbon aware programming construct, which are more suitable to underlying infrastructure. So looking forward to that area, quite a lot of interesting stuff happening. Yeah. But the first thing I would definitely say is start becoming better aware of this topic. Develop your mechanical sympathy to know better hardware, develop your climate sympathy to understand what happens when that infinite loop of yours runs on a program, on a machine, which runs throughout the day in a data center and consumes electricity and water.
Interesting. So in so much of good, I would say, tips that you've given, Dinkar, starting with looking at your selecting right cloud providers, looking at the design patterns and making sure you do good choices while coding, or things like understanding what your climate debt is, right? Or applying a green premium on somebody who may not be following such standards. So I think, and there's so much further scope for us as an industry to come together and make sure some of these standards get established. And I'm sure we would love to hear some of your thoughts in our subsequent sessions as well, where we go deeper into each of these topics and understand a lot more. So thank you again, Dinkar, so much for coming here today and sharing your thoughts. I'm sure for the listeners in this would get some ideas, some tips for them to get started. And the whole purpose of EcoITCon is to spread this awareness that yes, IT is not something which can happen in isolation. IT needs to also be an equal party to the conversations around environment. So with that, thank you again, Dinkar, for coming in here today.
Thank you, Archana. It's always a pleasure to exchange with you. Looking forward to next time. Thank you.
Thank you. Thanks.